Glendale Community College, Chem 130 students. This is going to be a presentation over Chapter 15 on solutions. So what is a solution? A solution is defined as a solute dissolved in a solvent. So now you're probably wondering, what is a solute and a solvent? Well, the solute is the chemical present in the smaller amount, and the solvent is the chemical present in the larger amount. So for example, if we have some tea it's in water, right? So tea is the solute and water is the solvent. In fact, water is the most common solvent. We have a lot of beverages where water is the main solvent, and we do a lot of chemistry where water is the solvent as well. So concentration, we have some qualitative words we use, concentrated and dilute. Basically, concentrated means there's lots of solute in the solvent, so the solution is very concentrated. And if there's only a little bit of solute in the solvent, then it would be called a dilute solution. Now, if you have a drink and you say it's strong, what you really mean it's concentrated, but no one really talks that way. No one's like, "Ooh, my drink is concentrated." But that's really what you mean technically. And if you have weak coffee, doesn't taste very good. Again, what you really mean is your coffee is dilute, but no one says that, they say weak, but what they mean is dilute. And here's just a picture of some cranberry juice from dilute mixed with water all the way up to full strength where it's a very, very dark red. So that would be concentrated, and the pale, pale pink would be dilute. There are many examples of the physical states of solute and solvent. It's not just always a solid in a liquid. For example, we can have a gas in a liquid like carbonated soda. We have the CO2 gas pushed down under pressure into the liquid, and then when you open up the carbonated soda, some of that gas is released as the pressure becomes less and you open it up. So you can have a gas solute in a liquid solvent and make a solution. We can also have liquid-liquid solutions. Most of our mixed beverages, alcoholic beverages, are this, like vodka and tonic. You have the vodka solute in the tonic solvent, and that makes a vodka tonic solution. So liquid-liquid solutions are possible. And then the most common is probably solid solute in liquid solvent, making a solution, like a saline solution, salt water. We have a solid sprinkled into the water, it dissolves and makes a solution, where salt is the solute. Finally, we can even have a gas solution, because all gases mix together. Air is not just one gas. Do you know what the main gas in air is? Okay, it's not oxygen, it's actually nitrogen. Nitrogen makes up the majority of air, where oxygen and all our other gases would be the solutes in the nitrogen solvent. So air is a gas solution. And finally, we can have a solid solution, like all your metal amalgamations, like steel. Steel is mostly iron with a little bit of carbon. We have stainless steel, we have sterling silver, we have brass. All of these are not in the periodic table as a metal, but they're two metals combined together, or even more than that. So they're solid solutions. So the point is, the physical states of the solute and solvent can be solid, liquid, or gas. So liquids with other liquids. We follow the like dissolves like rule. What does that mean? What is like? Well, like is referring to the polarity, meaning polar solutes will dissolve in polar solvents. Non-polar solutes dissolve in non-polar solvents, and then polar and polar do not mix. Okay, they won't mix. When two liquids do mix together, we call them miscible. And if they make layers and they don't mix, they're called immiscible. Now, miscible and immiscible are only used when you have liquid-liquid mixtures. Okay, so liquids that do mix, miscible. Liquids that don't mix, immiscible. Solids and liquids. If a solid dissolves, it is called soluble. If it does not dissolve, it is insoluble, and the solid probably just sinks to the bottom. So we have solubility rules on our table. These solubility rules are only for ionic solids in water. Now it doesn't say that, I wish it did, but it's the solubility rules for ionic solids in water. But not all solvents are water. So we're going to take a break and I'll come back in just a minute to finish this up.